Two very good concepts here rolled up into one problem. Actually, three, if you consider that we're dealing with tables of values, again, which generally seems to be a weakness with a lot of my students, and I think students across the country. I'm going to focus on the second part of this, the average value of g of x on 1 to 4 first. And just a reminder that the average value is going to be 1 over b minus a times the integral from a to b of g of x dx. And in this particular case, 1 over 4 minus 1 times the integral from 1 to 4 of g of x dx. The thing that makes this problem unique is that we don't have a symbolic representation of g of x, so we can't just find the antiderivative and use the fundamental theorem of calculus. We have to go to a numerical integration technique. And that numerical integration technique is called the trapezoidal rule. And the trapezoidal rule is going to be focused on evaluating that integral. So we'll go ahead and keep that 1 over 4 minus 1, which is 1/3, out front. And remember that the trapezoidal rule says we'll have b minus a over n, or I'm sorry, over 2n. So that would be b is 4 minus a, which is 1 over 2 times n, and we were told that n is going to equal 3 because they've asked us to use the trapezoidal rule with n equals 3 right there. Now evaluating this thing, we're going to have g of 1 plus 2 times g of 2 plus 2 times g of 3 plus g of 4. And these values right along here, we're going to get straight from our table. And if you were to look, g of 1 is a value of 3. Put 3 in there. G of 2 has a value of -2. And don't forget that we're going to be multiplying that by 2. Plus 2 times g of 3. Go down to g of 3, that's 1/2. Plus g of 4, and g of 4 from the table equals 6. Time to clean up. We have 1/3 times 4 minus 1, which is 3. Those are gone, giving us 1/6. Times, and we need to sum up 3 plus 2 times -4, 2 would be -4, plus 2 times 1/2, which would be plus 1, plus 6. 3 minus 4 is -1, plus 1 is 0. 0 plus 6 gives us 1/6 times 6, a final answer of 1, and that is a pretty nice little answer there.